All right, so welcome to I guess this is the September 27th meeting of Resource Management Working Group. Got a number of the items on the agenda. So we'll kick it off on the first item, which was Renault's device plugins 1.9 objectives, which leads into some of the areas that Vikas and Vish were just chatting about. So Renault, are you comfortable leading the conversation?
I'm on the call. Do we want to start immediately with the network we were talking about, or do we want to go and one by one on the objectives?
Actually, I would suggest we start with the stability item.
I'm sorry, I couldn't hear you, Jane.
I think I would suggest we start with the stability part to make sure, like in 1.9 we finish the planned work that we think are very critical for device plugin to enter beta.
Sure. So, well, I think even before talking about stability, I'd like to make sure that we have consensus on the fact that we want the device plugin to enter beta in 1.9.
No, I think like those are two separate topics. I think beta is a completely different thing. Let's first talk about like making sure the current existing alpha design we have is sufficiently consumable in some reasonable production environments, at which point I strongly believe that like more and more people will start adopting it, and then we'll get feedback, and then we can decide on when we can take it to beta. Like without having 3 to 4 kind of like different implementations, I think it's too early to take it to beta. And there's also like some discussions on what would be the right extension point for cluster level resources too. And so far, like device plugin role hasn't been like fully solidified. So that's also going to take some time. So what I would recommend is like, given that we only have 6 weeks left for 1.9 realistically speaking, let's not even bring up the beta discussion. Let it continue to remain in alpha. Let's focus on making sure whatever core pieces we have are solid and robust. And so then when people want to like extend it or add more features on top of it, they won't like work on top of a fragile core. So I think I'm going to +1 Jiang's point on making sure that the existing code that we have is stable and maintainable before we like open the gates for like further future features. Okay,
that makes a lot of sense to me. So let's go ahead with stability in that case. So I think the first thing to address is the fact that currently the tests unit testing are very flaky. I was looking into it a bit more yesterday. I might have found a solution. I have a few implementations different, but I think this is the first thing we want to at least handle as an objective. But I think, Vish, you mentioned mostly that you wanted to have a document that specifies exactly what stability means to you last time we went. Do you have any definitions that you might at least contribute to right now?
Yeah, I mean, concretely, the thoughts that I had were, one, that like device plugin should scale for reasonable churn. So let's say we're creating like or 50 or 100 pods in like rapid succession. It should continue to work in that scenario. And so I mean, basically we have both like density tests and soak tests. We should run the existing infrastructure through those density and soak tests. And we should also, soak is also going to like make sure that the whole plugin infrastructure remains stable over time. We already have pretty awesome tests as part of 1.8 for like doing more intrusive testing by like restarting different components and seeing if they're working fine. So I think like we should just run it more in like both density and soak scenarios. I feel like those are some of the ways for us to like generate more signals. Other than that, like we've also like identified a few specific issues that have to be fixed. One is the code complexity. It's pretty high right now, and it's kind of subjective. So I think like there's been overwhelming feedback from core maintainers that the complexity of the existing code is quite high, and so there's a general want to reduce that. So that's another concrete item. But other than that, I haven't like spent time in the device plugin area in the last month. So not like on top of all the other open issues around that.
Yeah, one thing I had in mind here, Vish, and I also am unfortunately not, I might be a month removed as well, is do we have any way of measuring the kubelets interaction with the device plugins today from a Kubernetes metrics collection standpoint?
No.
Like we have a lot of stuff around like how we're doing with the container runtime, and that's weeded a lot of issues. Like I kind of feel like we're flying blind on the device plugin side, and that would be a key criteria for me to get closed.
Absolutely. Yeah, I mean that's important for us to take this into production too. So yes, like having ability to introspect the current performance and so on is very important.
Yeah, actually, I would suggest like maybe we should have some testing libraries for that different device plugins can use to test their device plugin implementations. So we will need E2E test, and in the E2E test, I hope we can also support some like to measure the CPU and memory resource usage of a given device plugin, and hopefully we can use it to run some stress test.
So the particular plugins, I think we should be able to collect just with the normal infrastructure, right? I'm making sure that we have coverage on the interaction with the plugin itself on the kubelet side.
Yeah, I kind of second what Derek was saying, in that the core responsibility of open source Kubernetes and upstream is not specific device plugins and how much resource they consume, but it's rather the code that's in the kubelet and the API itself. Okay. So I think I mentioned this offline, right? Like I think one of the things that we can do that will greatly benefit upstream is like have a stub implementation of a device plugin that will let us test conformance of upstream without needing GPUs or anything of that sort, right? Like basically we just test the whole infrastructure without requiring specific hardware and specific plugins.
So I think on the testing part, there are definitely like two parts. So on the Kubernetes side, I agree we want to have like a fake device plugin implementation that we can use in the E2E test and E2E node test. That just test the kubelet part to make sure it doesn't have any regression, doesn't have any performance concern. But I think it's nice to have to also have some like generic testing library, like different device plugin implementations may just reuse. And it also kind of like set the expectation, like what kind of functionality and stability we expect from device plugin.
So just a quick, we do have a stub plugin for the at least unit testing, but from the E2E point of view, is where I'm a bit more confused on how we would do that. You mentioned the pipeline Vish, but I'm still a bit unsure how we expect to do the stub device plugin into the E2E, because we have to generate an image, right?
Correct. I have some very specific thoughts. Maybe you can sync on that offline. I don't know if we can like discuss that verbally. It's much better discussed through like a doc or through an issue. But at a high level, I was thinking that we can write a dummy device plugin which will expose a resource foobar. It doesn't really have to be an actual resource. The only thing that we're testing is the whole Kubernetes infrastructure works.
So I'm curious, I know Sally, you're on the call. You guys may have run into this with SIG auto scaling around testing the custom metrics pipeline. Do we have any similar experience around like dummy providers that we may or may not be able to glean from this group?
Hold on one sec. I gotta switch headphones. My headphones aren't working properly.
You got the best microphone.
Yeah, it's got a great microphone, but How about now, Sally?
Okay, can you hear me now?
Yeah, did you hear the original question?
Yeah, so we have actually been discussing this problem ourselves right now. Our plan, at least initially, is for kind of to have a similar kind of a dummy implementation of the custom metrics adapter that will just allow us from end-to-end tests to say, populate these given custom metrics. And kind of the thought was the same idea, right? Like, we want to be able to test things without needing, a full metric setup, and B, without having to be concerned that, maybe we're breaking the test not because of something that's wrong with core Kubernetes, but, I don't know, there was a bug in Prometheus that happened to cause it to return -3,000 or whatever. Like, we were thinking about going the same way, and then there were people who were in the sig-auto scaling who were interested in setting up kind of non-blocking end-to-end tests with specific metrics adapters. But certainly for like the official blocking end-to-end tests, we were looking to go in the direction of having a dummy adapter.
And then for the other comment on like, should we have like a dummy or like a device plugin SDK, which is what I think Jan was talking about. Like, I know you tried to do that in sig-auto scaling right now. Has that had much success in your view, or has it been worth doing?
Yeah, well, I mean, so I think it's helped get the stack driver stuff off the ground pretty quickly, more quickly than it otherwise would. So I think that's been successful. Besides Stackdriver and Prometheus, there haven't been a ton of takers so far, but I suspect as we move towards, GA, we'll probably have some other monitoring solutions.
Vikas and Renaud, you guys were the ones who were implementing plugins, right? Like, is there anything common that you think would have been beneficial to share to provide like an SDK of sorts?
So the device plugin I implemented for NVIDIA devices, which I hope we're able to publish as soon as possible. At least on the communication part, I didn't see any parts that were really redundant, or that could have been generalized.
I think what we were talking about were like basically having a test suite which any device plugin vendor can run to make sure that their device plugin is conformant, and so that we can split the tests in two parts. One is a test for the kubelet side, where we use an end-to-end dummy plugin to test that, even for like both for unit test and for end-to-end test. And for all the other like vendor-specific device plugins like NVIDIA or Solarflare or whatever, we have like a conformance test suite which those vendors can run to make sure that their device plugin works. So I think that was one of the things which I think Jang was talking about to like have a SDK type of thing which people can run and make sure that they're.
Is there a reason to have that, set of conformance tests not necessarily just be part of the end-to-end tests, and then just make sure the dummy adapter implements them, right? And then say, you should be able to, if you drop in your device plugin, instead of the dummy adapter in the end-to-end test suite somehow, like have like a flag or something that says drop in this adapter in the end-to-end test suite, you should be able to run all the node E2Es with your adapter instead of the dummy adapter. And then that way there's not like a split set of tests or anything. It's just very clear. You should be able to run the node E2Es. And if you can't, then you have a problem. If you can, then you can be reasonably certain that your thing will work properly.
Yeah, with a separate one, like you will not be dependent on Kubernetes tests to run. Like the device plugin code is kind of separate, and you can just run those tests to test your device plugin functionality.
So I think we already have ability to collect Prometheus metrics and like dump them into a shared Prometheus server, which is what we use for like tracking kubelet performance, for example, or like API server, pod startup latency and scheduling latency and so on. So I think we already have an infrastructure. I just don't know how easy it is to reuse it, but we have one, and so I think like this is less of a concern for us. But I do want to stress on the point that Ro just talked about again, which is the responsibility of open source and the tests that should ideally affect like submit queue and releases should not be tied to any specific device plugin. because the responsibility of the core is to provide this extension point and not necessarily support for each and every artifact that's being supported through this extension point. Because if we go down that path, then we're sort of defeating the whole point of extensibility. But it's up to each vendor to make sure that either they use the upstream Kubernetes testing system or not, and make sure that their overall integration actually works. Right. So we do want to add value for the Kubernetes ecosystem, but I want to make sure that the responsibility is very clear between like the core upstream versus the ecosystem.
Mm-hmm. Yeah, exactly. So other than the parts, I also think maybe in 1.9 we may want to have some kind of upgrade and downgrade tests for device plugin, especially if we want to change the API.
So actually, that's a pretty good transition to the next part with which I called usability, but we can rename if we want to. It was more as a first draft for the name. So my point of view on the current API is that currently we support NVIDIA GPUs with Google's device plugin, and the idea I had behind this part was mostly because on the last, at least for the 1.8 milestone, we started saying that we would like to support Solarflare next, but unfortunately we couldn't. And so, in my point of view, we don't really have a plugin system if we only support GPUs. And so, I agree with the fact that it's a bit annoying to specify our objectives in terms of supporting a specific device. But I think it would be a good objective, at least for 1.9, to say that we support two kinds of devices, even if these are Solarflare devices supported only by Red Hat that Vicus is implementing. Does that make sense?
No, I mean, I think we're all completely on board on the fact that we want additional implementations and we want this API to actually help the ecosystem. So there's no questions about that. I'm just saying that in terms of prioritizing the work for upstream, there are two paths. One is like stabilizing the existing core. And I'm saying that that's P0. And then there's the P1 item, which is like extending the existing API to meet additional use cases for adding support for new devices, like the Solarflare mix, for example, or like maybe InfiniBand and so on, right? So there are, and I just want to like stress the fact that we should not like let go of the P0 and we should not have a priority inversion, because the things that we are doing as part of stability is going to benefit everybody, right? So
I completely agree with
yeah, wish like I want to just say here that from the Nix perspective, the only change in the API that we are asking is for just the pod name and not even the complete pod spec, and that will help all the Nix, that is like InfiniBand and Solarflare and maybe any other as well. So we should also look that like how much complexity or instability this change is asking for. For example, for the Nix, the request which we are making is just for a pod name. So, and that could be useful, as you said, for other device plugins as well. So
yeah.
And I don't think that we should really couple it with the multi-network supports. Anyways, multi-networks have been under discussion since last around 2 years, and still today there are no clear conclusions, like, and chances are more that it will be outside of the core cube. So, and device plugins are also going to be outside of the core cube. So I don't think that we should really couple it with like how multi-networking is going to be implemented, because
can you please like do us all a favor? Can you like write a one-pager describing what is the architecture that you're taking for managing Solarflare? You don't necessarily have to get into the hardware details, but at least like if you can share a one-pager that like describes your high-level architecture and why you think device plugins is the right abstraction, and can you, and if you can highlight like why this PR that you posted for exposing the pod name is relevant, just that, because that'll help like have conversations with some of the network folks and maybe like decide on the priority for multi-network, right? Like maybe it's not necessary, but without that data, like I can't have a conversation.
I also like think it will be really helpful for us to understand the problem and say whether it's a right fit for device plugin. And it will also help us to defend the long-term scope of device plugin, because I think at the beginning we just want device plugin to be device plugin, but we do see some requirements, some new requirements, and we want to say whether we want to adjust our long-term scope.
Yeah, so we're not saying that we should not do this. I hope like that's clear. All I'm saying is like let's communicate as clearly as possible our requirements, and so that like when Kubernetes as a project is giving other users guides of like how to extend Kubernetes to meet their use cases, we give them like confusing guidelines.
So
that's the primary goal.
Just because I guess I'm curious on this one. So like on the GPU side, correct me if I'm wrong, I thought we basically require run C hooks in order to actually get a whole solution. Is the passing of the pod identifying information like the basics you would need to do some stuff that don't have run C level hooks?
So like I want to clarify just one thing and then like hand it off to Vikas. The thing is that run C hooks are claimed to be necessary by NVIDIA, but we, at least at Google, have been able to run without the hooks as of now. Maybe we are probably lacking some of the functionality that we do out of run C hooks, but from a functional standpoint, things seem to be working for now. And if we get to a point where the hooks are necessary, then we're also like exploring other means rather than like having to have a runtime level hook because we want runtime portability. But that's like completely aside from this conversation.
Yeah, and also
if namespace and name without UID are sufficient.
Yeah, but my feeling is if we start to head in the direction to pass the pod information to device plugin, different device plugin can use that information to do like a lot of things, and we may start to have more fragmentations in terms of how we manage different kinds of resources. So like that's why we hope we can better understand the use case and say how what is the best way to support those resources in Kubernetes, because we don't want API to be too flexible that it doesn't really do any kind of enforcement in terms of the Kubernetes model.
Okay, guys, I'll try to write up a document with the requirements, mentioning the requirements clearly, and we'll discuss over that then.
Yeah, so, I don't expect it to be controversial at all. It's just to
yeah.
It's just to like what we're trying to do with this.
Yeah, makes sense. Yeah, I'll write it up. Thanks.
So,
thank you.
Just to build on what Jane said, this is something I've intentionally left out of the objectives for 1.9, which is the new resource model that Vish talked about, which I felt was something that you're more targeting for the next milestone, so 1.10. But do you have any more thoughts on that, Vish? Am I wrong on that? Are we thinking about it, or you were mentioning a few times if you had a model in mind and that you would publish a document?
Yeah, it's necessary for certain scenarios, like mainly for applying quota limit range, and like making these extended resources easily visible through like command lines and UIs and so on. So I think like there's an immediate use case for it. And the thing is like, because already did some great work on exploring some of the resource plugins. So the thoughts that I had were like to extend that. And Derek and I sort of had an offline conversation about it when we met a couple of months back. But the thing is like, I'm hoping in this 1.9 time frame to actually propose a design which will like cover extensibility across the board. And this is something that we have to discuss with the overall like community and not just like us, like as in this cabal. But yes, like I think I do want us to start tackling that in 110. But for 1.9, I would prefer we focus on like getting the existing baseline solid and not like spend too much time on that, because we only have.
Agreed. This was more as an interesting as in how we are going to see evolution of that as a kind of question. So I guess the last objective I had in mind, which is less tied to the 1.9 milestone. I named it rewording because the objective was to have to at least reword in a first time the document, the design plugin document, so that it's easier for us to evolve to a, or at least for the CSI. To give you more context, we had a meeting with Tim Hopkins and Vish, and the concern was that we have two plugin systems, or at least three plugin systems currently in Kubernetes, and that if we have three plugin systems, then maybe we can converge.
Can you enumerate the three, just so that we're all on the same page?
The CSI spec, the device plugin spec, and the last one is the networking plugin, which I can't remember the name. So CNI, thank you. So the Tim's concern was about the fact that if we have three different plugin systems, then maybe we could at least converge to something that's, if not unified, at least similar. And so the idea behind rewording the device plugin spec to make it at least similar to the CSI spec was that so we could actually move forward to this similar, at least in the first time, a specification, or at least design. Also, I think it's important. I feel like the CSI spec is a lot more professional than the one that I've made, and is a lot clearer. Which I still feel today that the device plugin spec is a bit messy.
Oh yeah, totally. I just didn't know if I said that how many hearts would break, but we have done great work. But then from the storage side, it's a really it's a 30 or 35-year-old domain, and like even on the Kubernetes side, there's been lots of iterations on the API that have happened. There's been like the in-tree volumes, and then there's the out-of-tree volumes with dynamic provisioners, and then there's flex volumes, and then we have this containerized volume. So we're like tried this over and over. And then came the device plugin spec, and then like it's this sort of like multi-orchestration consortium thing that's doing it. So there's like a lot more energy and bandwidth going behind it. So I mean, I don't think we should like give. I don't think like we should demean ourselves too much. I think we have done a good job with the time that we had, but definitely we can do better. So I did talk to Saad, and I did explain to him some of the design primitives we have chosen, like in terms of having dynamic registration and the auth model we have chosen and so on. So he was like pretty positive about that, and he was trying. It was actually like helping solve some of the CSI use cases too. So he said that he would be taking a deeper look into our device plugin model and seeing if they can incorporate some of those design primitives in the CSI spec as well. From a CNI side, it's like it's like a binary exec model. So to satisfy Tim's question, I think what we need is like a doc that contrasts features provided by each of these different extension points and the specific design choices that they have chosen for like providing the actual functionality and like where they hook into the pod and kubelet lifecycle, and then what sort of auth primitives are necessary. Like how does one write a plugin? Do they have to deploy a binary or not? Like how is lifecycle of the plugin handled and so on? So it's more about like highlighting the different design choices and assumptions made for these different extensions. So from our side, from the device plugin side, I think we can supply that. We have probably adequate information already. but we probably have to collaborate with the CSI team and the CNI team to generate this. I can try to get this conversation going in 1.9 timeframe, but I'm really not positive about that. This might slip into 1.10, and we can say that this is something that we need for beta. But I don't know if we can do this in 1.9. We can try, but I'm just trying to be optimistic.
So in my mind, this objective is a lot less tied to a specific milestone, because it's really about the like evolving the current spec to something that we all agree on, which in a 6-week time frame seems very unlikely.
Yeah, we need like 3 to 4 implementations for us to like first finalize the functionalities that we want to provide and see whether the current model we have chosen is actually going to work. Like for example, in the case of CSI, there's probably about like 20 plus implementations that would show up, and so like there's a lot more data available there to make the right design choices, and here we don't. So I think we'd probably benefit from advertising this feature more in the community. And like increasing awareness in this 1.9 time frame, so we can have more and more people trying to use this API and start filing issues or like start identifying feature gaps.
I think just to recap what we just said, mostly we have really 2 objectives. Well, the first one is stability, which is P0, and the second one is real about talking about supporting new devices, at least API-wise, which is really more P1. So the stability, I think, is something Jiaying and I are going to at least take offline. We have a few plans, a few issues to open and a lot of PRs to review. And if there are really some like at least some major concerns or plans on how to do specific things, or at least the first one I think I've noted was really about having this stub a device plugin E2E. We can write a document on that. Does that seems correct to everyone here?
Yeah, that sounds good, and I think we can continue the discussions on on issues and the PR reviews. I would suggest for any working items we start by creating an issue, a feature request, and then yeah, you and I we can discuss offline, and maybe we can also see whether we can offload some of the working items to other people.
Yeah, and the only thing that I would say is like if you discuss anything offline, just make sure that the information is available as soon as possible to the rest of the community, so that I mean other people can also help out in this effort. Like,
yeah, I think these discussions, the PR discussions are like better. Yeah, definitely.
So just to conclude on that, I do want to make an action item. I'm not sure who it is. It's this stud device plugin. I'm still a bit unsure on how we would do that. And if someone wants to take that task on or of writing a document,
let's figure that out offline. Let's like first step is to like list down all the requirements so that it's available on GitHub, and then let's find out owners for each and every one of them.
Yeah, I think there's already.
Okay.
Because there are a lot of people who are probably not on this call who are also like very much interested in helping out. So I would probably like wait until all the information is available clearly on GitHub and then start figuring out the owners. Unless someone is like really interested in doing that, by all means, please go.
I think some people are. Okay.
Okay, so we only have 20 more minutes and there's 2 more items in the agenda. Should we move on?
Yeah, I'm not sure how much we're going to get on particular items. I mean, I'm fine to move on unless we know you had other topics. I guess we're good to move on. So, like Vish, I'm still probably, or many of us, getting over 1.8 and thinking about what I'm going to do on 1.9 is daunting. So just threw items on here for the work that we did in the prior release to start thinking about what we want to do to change. on the huge pages side, here at Red Hat, we have actually validated this work now in a number of different areas. The major part of the implementation that I struggle with right now is that, like, I think there's some confusion on having huge pages being tied to quaz or not. And basically the one thing that's been bugging me on this since 1.8 is I think the directional bias I'm leaning towards is basically, given that the number of page sizes may vary on given architectures, you can't like expect a user to make an explicit enumeration across all of them to have it ever actually be a part of our standard quaz model. And so I've been leaning towards the real world use case of this is like, if you consume huge pages, you're also consuming normal pages. And so the basic assumption I'm making is that, like, in order to use huge pages, you must make a normal memory page request as well, and not tie huge pages to actually the quaz class or not. So basically, I could be a guaranteed pod without making a huge page request. Whereas right now, I think when this alpha feature is on, you cannot be a guaranteed pod when making no huge page requests, which I now realize saying that if that was true is backwards incompatible, and that's the one item that I've been thinking that I needed to fix. But from like a usability standpoint, I think so far this seems okay. I'm not in a mad rush to promote it to beta in 1.9 without getting some additional feedback. But I didn't know if anybody else from the community, maybe Intel or others, have started experimenting with their particular workloads using this. But this seems more isolated than, say, the device plugin side.
So Derek, huge pages are expected to be treated as integer resources, right? Except for the fact that there's this tie-in with C groups. But otherwise, like, they are just pure integer resources in that you can consume main memory aside from huge page memory.
Yeah.
So in that sense, like, they should not be affecting quaz at all. I might be restating what you just said.
Yeah, basically, if I have reason to believe that potentially in some part of the code I wrote in 1.8, it could have impacted quaz. I would like to clearly say that it should not impact quaz. But generally speaking, above that, I think to consume huge pages, you should have also made a memory request. Like, that's probably the one validation change I'd be looking to make. Like, I don't see a good reason for a best effort pod to really be consuming huge pages. So at minimum, requiring you to be in the burstable tier does not seem like a bad thing to do. But yeah, that was the one split. Otherwise, the restrictions we made around limiting the number of page sizes per node, I don't really think are that problematic.
I just feel like the restriction around best effort pods not consuming huge pages is probably generically applicable to any other resource, right? So maybe if you're coming up with a solution, I'd probably...
For integral resources, you mean generally?
Yeah, I mean for other integer resources too.
So that would include like devices and...
Right, yeah, any sort of like extended integer resource too.
Yeah, I'm not sure about things that we used to say were opaque or not, but and there's less of a resource I can so closely tie it to that I don't know the answer to that one, I guess. But generally speaking, I want to make sure that huge pages are not a part of the quaz model, but users who consume them have at least a burstable quaz.
Yeah, I mean, we need some policy to enforce it mostly, right? So maybe like admission control or something.
Yeah. Other way, from a code standpoint, I don't think there's a ton of cleanup there now. I think Avesh and Seth worked out the scheduling changes. The other items that come to mind that we did not do was exposing it down through the CRI. Right now it's at a pod sandbox level. That's something we could look to do. And also then support per container isolation. I'm not sure in my own view of what our other 1.9 priorities are that's something I'm motivated to sign up for right now. And in particular, it seems like that's a broader change to push through.
Yeah, let's just file an issue for it and then see if people actually want it.
Yeah. Otherwise, pod level isolation seemed fine, but for the most part, I don't have a ton of bad feedback on what was done so far, and it seems like the constraints we ultimately arrived to in 1.8 have not been proving problematic.
Okay.
Leave it at that. So on the last topic here on CPU Manager, given that Connor's not here, there were a number of items that I called out during the review of those PRs in 1.8 that I wanted to get solved before ever thinking about moving to beta. And I wasn't sure if any of the folks here were on the call were interested in exploring other CPU management policies. So like a lot of work went into the static policy, not much is happening in the alternative policies. So I'm curious if anybody has an appetite for that. Right now, I don't think from Red Hat we have an appetite to solve the dynamic policy in anywhere at a 1.9 timeframe, but just wanted to get the pulse of the community. Because I think Huawei expressed some interest.
This is Balaji here. There is one issue to tracking all the list of items to graduate CPU Manager from alpha to beta.
Yeah.
But that only includes the restart cap that we have already talked about. But that list will grow and will include other items that we can look at in that issue.
Okay. So given that Connor's not here and Bajat, we only have those two identified. If we just want to rally on that issue, that's fine. Do you know if you guys are willing to sign up to actually close the restart gap in 1.9, or is that something that we'll need to pull from the community to help do?
I think we'll be able to do it.
Okay. And just so folks are aware, right now, if you restart the kubelet, another container might get the same core reallocated to it. So you get pinned, but it might not be exclusive pinning. And the issue is we did not have a clear place to checkpoint that state or discover it back through the, I guess, container runtime or the secret hierarchy.
But then it'll like over time it'll stabilize, right? Or is that like a permanent situation?
I mean, your work will never get moved to another. Well, Seth, correct me if I'm wrong here. It's been a few weeks since I reviewed the PRs, but basically, the same core could be reallocated out to another container if the kubelet restarted.
Yes, that's correct.
What's the plan? Is the plan to ask CRI to implement some kind of checkpointing, or
No, there are two options. Either we inspect, as Derek mentioned, like inspect the C group hierarchy and then reconcile state when the kubelet restarts, or checkpoint the current state of container and CPU allocation regularly, and then when kubelet restart, we just again reconcile using the checkpointed data.
And
I'm in favor of using the C groups because we already do that.
that's what I was going to say, but I wasn't sure where that may or may not break down. But yeah, my bias was to do that. The problem on that Vish is, like, right now, we only really introspect the pod sandbox C groups, but not very much deep into the container C groups, unless we are ensuring that all PIDs are killed before we delete the pod sandbox itself. But I still don't see a major problem in dropping down to the container C group to reconcile the state.
And the problem is, like, if we have VM runtimes, we may not actually know other C groups that are in there. I think at a pod level, if you're aggregating all...
Even on the VM one, the VM should have parented its C group underneath the pod sandbox. So it's more like when...
Good.
Yeah, I mean, in theory, that's what they should have been doing. In practice, who knows? And so, like, yeah, I'm biased to reconstituting state from the C group hierarchy itself. And assuming that worked out fine, that was a fine plan for 1.9 for me.
Yeah, I was just suggesting that while doing that, if you make sure that the pod C group has all the CPU sets that have been allocated to its containers, then that might be good enough for us just to reconstruct state. Because I assume that the main thing that we care about is what is available and what is free, right?
Yeah. Okay, so I think, I don't know if we had any other particular items to cover here. I don't know, Vikas, did you get to look at the if set priority syscall is still actually going to be needed or not, or did we work around that with Jeremy? He's not here to give input.
No, I could not take a look at that.
Okay.
So one more thing we may want to consider is like, if there are going to be device plugins that are generally applicable for the Kubernetes ecosystem, maybe you want to have some like document or some repository which sort of like collects knowledge across these different device plugins and like keeps them, makes them easily available for Kubernetes users. That's something that we might want to explore as a community.
Relate to that, like during some review discussion, we
Hello? Can you hear me?
different resources advised by different device plugins that don't conflict and follow the same kind of naming convention.
Right, yeah.
Maybe 1.9 we should also think about that and hopefully have some answer in that.
Right, just give some guidelines and have a few examples that people can use to clone and start developing their own plugins.
Mm-hmm. Okay, so we feel it may not necessarily like we have some kind of like authentication or like registering some well-known.
No, it's out of tree, so people can do whatever they want.
Okay.
And we can curate some well-known systems which are pretty popular, just to help the community.
Okay.
But the code is going to live somewhere else. It's out of tree, so
okay.
We're only like facilitating discovery.
So I guess the last thing I just want to make sure that from my perspective, there's no other things that we didn't already start in flight that I'm interested in pursuing in 1.9, and I just want to make sure that, I assume Vish, you feel the same way. Was there any other particular topics that folks thought that they really wanted to advocate for that we haven't discussed? And if so, I'd be curious what those were. And then, like, generally speaking, it's exhausting trying to get as much as we've been getting done. And so I'm, like Vish, more interested in trying to push stabilization for the next period of time on the things we've started. And silence is golden on that. Yep, we can hear you.
Hello, can you hear me?
Yep.
Yeah. I have one question about huge paid. I want to know, do we have any plan to support updating the allocatable huge pages of the node?
So like, I see, so allowing you to dynamically provision huge pages and then have the kubelet not be able to report them back to the scheduler?
Yeah.
Go ahead.
Yeah, my initial thought on that is it was not a major. I mean, so this issue comes up also when people want to like dynamically add and remove CPUs. I had a sample piece of work out there that basically provisioned huge pages from a daemon set, and at the end it kind of kicked the kubelet as a restart, as a poor man's restart, which was fine because it didn't really impact users' workloads. I'd be curious if that type of model would work for you now, just so that we can avoid having to support dynamically updating allocatable values back from the kubelet at this point in time.
Yeah, I mean, just to add to that, I don't think the system is designed to handle dynamic capacity changes, especially like reduction in capacity. So I would, like, if you're going down that path, that would require a much more deeper thought. So like huge +1 for what Derek was saying.
I mean, generally speaking, yeah. I mean, even when we're changing certain config flags, like I could see people wanting to dynamically increase their system reservation potentially, but even then I'd be motivated to want to do that with a kubelet restart. So
I don't know if like kubelet restart by itself would help, Derek, because in like kubelet restart is not going to go ahead and like evict pods that are already running. Neither is node controller actually going to understand the reduction in capacity and take some action. So it's, I mean, the ideal scenario would be that you would drain the node, create its capacity, and then reprovision the node.
I guess
it is a new project.
For the original question, I'll paste a link to a small GitHub repo I had, which was a dynamic allocator for pre-allocated huge pages that you could do via a daemon set. In practice, I'm not like the biggest fan of it because typically we wanted to pre-allocate huge pages as close to boot time as possible. So none of what I will paste here actually handled like what happened if you could not actually get all the huge pages allocated, if the node was actually under heavy use. So be curious if you wanted to pursue a model like that externally, but yeah, right now at least I'm not heavily motivated to go and make allocatable, updatable in 1.9.
Okay, thanks.
Okay.
So one more thing that I wanted around CPU manager work, which I was trying to ask Connor and Balaji during the 1.8 timeframe, of having some repeatable benchmarks that we can run in different environments. That will like inform users if they need static pinning or not, right? Like they're going to probably have their own applications that will inform them, but they can also like run this other benchmark that we curate, which will help them make decisions on what sort of performance optimizations they actually need.
Sure.
Go ahead.
So I'm working on initial performance benchmarking report right now.
Awesome.
At least with bare metal environments with certain benchmark workloads. Also, Nicholas Nielsen is on the call, and he might have something to add to have a more generic suit for performance benchmarking for CPU manager or otherwise for Kubernetes. Nicholas, are you there?
Yep, I'm here. I think Vish, you know the context of what we've done in the past, but I guess it would be more interesting to kind of measure concrete metrics like context switches or something that could give people like a low-tech view of if they need to pin their workloads or not, if they're actually contending for something. I don't know if that's something that we're gonna work on immediately. It may come down the line.
Okay.
Those are pretty inconclusive, but I guess like what Balaji is doing now is probably what you're gonna see. Like,
okay. I mean, if this benchmarks can be run on most Kubernetes clusters, that itself is a great start.
Yes. So we are using containerized workloads. So I'll also provide all the pod specs and instructions to run it on any cluster with or without the CPU manager enabled, and post some example results.
Yeah, I think that should be good enough to start with. That's what I was primarily hoping for. But yeah, as you said, Nicholas, I think we do need to expose more signals to inform users what sort of optimizations they actually need. And that's sort of like taking us down the road of like automating some of this on their behalf too.
Can we share some PR document on the benchmarking set?
He's going to.
Okay, great.
Okay. So we're coming up on the hour. Any other topics you want to cover today? Otherwise, we can adjourn and get back to chatting on these things on issues and Slack. All right. Well, thanks everyone for preparing stuff for today, and I'll talk to y'all soon. Bye, guys.
Thank you. Bye.